Your mobile phones are made up of many precious metals like terbium, tantalum, and neodymium. But to extract these metals, the mining industry goes through a complex process which has a grave impact on our
Many harmful
environment.
chemicals are used in mining in order to extract precious metals from the dirt. In turn, those chemicals can end up in the soil and contaminate it. This also implies that many bugs and other microorganisms in the soil may die
Another
off.
consequences of mining is groundwater pollution. Through rainfalls, the contaminants in the soil will be washed through the soil sooner or later and will contaminate our groundwater.
In mining, harmful chemicals like quicksilver, sulfuric acid, and chlorine are used to separate metals from the dirt, harming not only the workers but locals as well.
With all of these disadvantages in mind and many more, mining is not a sustainable way of collecting resources, as most of the minerals mined are non renewable and will be depleted sooner or later. A major solution to this can be asteroid mining. Asteroid mining is possible by utilizing the millions and trillions of rock, ice, and metal in space. As space travel has become more feasible, scientists have done research and conducted space missions like the Hayabusa, which was able to return samples from the asteroid.
The profits of asteroid mining could be in trillions or quintillions. One asteroid known as 16 Psyche contained up to an estimated net worth of $700 quintillion in heavy metals.
With successful research, scientists have separated the asteroid to three types: C type asteroids, S type asteroids, and M type asteroids. C-type asteroids have high amount of organic carbon, phosphorus, and other ingredients used for fertilizers which can be used to grow food, while S-type asteroids carry little water but more attractive because they contain numerous metals including nickel, cobalt, and more valuable metals such as gold, platinum, and rhodium. M-type asteroids are rare but contain up to 10 times more metals than
As
S-type
mentioned
asteroids.
before, there have been successful missions like Hyospa and Hyospa 2. They both used a probe to study the asteroid and then return a small sample from it. In principle, we need to build a bigger probes to be able to collect further materials.
Even though rockets do not compare to other industries in terms of carbon dioxide emission, but we can still utilize closed cycle engines like RD-120 and RD-181, which will have more complete combustion cycle and they can do more work with the same amount of fuel compared to SRBs, in turn reducing carbon dioxide
To
emission.
make our first major mining mission easier, our targets will probably be asteroids near. Once our spaceship reaches the asteroid, we need to secure it and stop it from rotating by using our thrusters. Then we need to put it into a stable orbit around the Earth by using the moon's gravity. This process may take months, but in the meantime, we can launch our first mining equipment to the asteroid. After our mining has been done, we may use reusable rockets to transport the minerals back to Earth and process them.
On asteroid mining, we'll invent giant mirrors which focus sunlight heating up asteroid rock to boil out the gases and grinders, breaking up the dried rock into gravel and dust. The centrifuges separate dense from light elements. Due to the weak gravitational field of asteroid, any activities like drilling will cause large disturbance to form dust clouds. These can be confined by some dome or bubble barrier.
Now that we have obtained our metals, we may use reusable rockets to send them back to Earth.
As we conduct more and more missions, the next one will be easier than the last. And with enough time and investment, we may reach a threshold in which we may not need to mine on Earth anymore. Thank you.